So today I want to talk about the roots of an equation, and we can see the roots of an equation on a graph. So we can see here a parabola. That's a curved graph here, and in fact this is the graph for the equation y equals x squared plus x take 20. We can see it's a quadratic. The highest order term here is x squared. A few things we might notice: we cross the y-axis in the negative. Okay, so it clearly crosses the y-axis at a negative point, and in fact it crosses the y-axis at the point negative 20. We can see the y-intercept there. We're gonna look at what the roots of a graph are. The roots of a graph are the points in which it crosses the x-axis, and I've noted those 2 points here. It passes at the point 4, 0, and it also passes at the point -5, 0. In other words, it crosses the y-axis twice, once on its way down here at -5, and then it crosses the x-axis a second time at the point 4. Okay, so 4 on the x-axis, which is the point 4, 0. So what does that have to do with the equation? Well, let's have a look at this equation. Suppose I gave you this and said, I want you to tell me what x is equal to. Okay, so when this here equals 0, in other words, when y is equal to 0, what is the value of x? So if you remember your factorizing, you can see that this factorizes. So I'm just going to factorize this. That's going to be an x. That's going to be an x. And we just need to work out what goes inside these brackets, don't we? Well, how do I make -20? I can use 4 and 5. And let's just have a think. I need those two numbers to add up to make 1, because this is, one lot of x. So let's just check we've got this right. I think we need a 5 and a 4. I think we need it to be a +5 and a -4. So 5 times -4 is -20. 5 add -4 would be 1 for the 1x. If you're not sure about that, you need to check over last week's assignment and have a look at factorizing. But let's think about what this equation here actually means. It means this bracket times this bracket equals 0. Now, when you times two numbers together and get 0 as an answer, that tells you that one of these two brackets must be 0. Because if neither bracket was equal to 0, you wouldn't be able to get 0 as an answer to that multiplication. So it doesn't matter what one bracket equals, as long as the other bracket is 0, that will give you a solution to this. So let's imagine that this bracket here is 0. Let's imagine that x plus 5 is actually equal to 0. What does that mean that x is? Well, if we follow the process that we've learned, we take 5 from both sides. That's going to give us x equals -5. Okay? What about the other bracket? Okay, x minus 4 equals 0. So what would x have to be? Well, I hope you can just see that x needs to be 4. A number take away 4 is 0. That number must be 4. We'd find that by adding 4 to both sides. And actually, these are the two solutions. And quadratics, you'll find, often have two possible solutions. You factorize them in this way, put it equal to 0, and then either this bracket is equal to 0, in which case you get one solution, or this bracket is equal to 0, and you get this solution. And I'm hoping that you can see the relationship between this and the graph. -5, 4, -5, 4. These are telling you what the roots are of the graph. They're telling you where it crosses the x-axis. The reason for that is that these are the points where y equals 0. Y is 0 here, y is 0 here. This line, this y-axis is at 0 here on the x-axis. Okay, so graphs don't always have two roots though. Let's have a look at a couple of other quick graphs. So let me draw you this graph. Okay, let me draw you a graph that looks like this. How many times does it cross the x-axis? It doesn't. This graph does not does not have any real roots at all. So at no point can we have a situation where y equals 0. Y is never equal to 0 as part of this graph. Okay, so this is a quadratic, but it has no real roots. It never crosses the x-axis. There's another kind of graph we might consider. A graph that looks like this. Okay, how many times does this cross the x-axis? Well, if I've drawn this right, it crosses at exactly 1 point. So this would be a quadratic, and this graph has one real solution. Okay, so I'll write this down here. We've got one real solution. Okay. In this case, in this situation, this graph just kisses the x-axis at just one particular point. So you can see the three different situations. We either don't cross the x-axis, we kiss the x-axis and just touch it just that one time in that one place, or we cross it twice. And I'm hoping that you can see that with a quadratic graph in a U shape or an N shape, we're only going to have those three situations. We can only we're either going to kiss it, we're going to miss it, or we're going to hit it once on our way in and then hit it again on our way out. Those are the three different ways this can go, and it's only going to go those three ways. Okay, so I think we're ready now to have a look at a question. Okay, so here is a question. Below is a diagram showing part of a parabola in the form y equals ax squared plus bx plus c. Okay, so let's have a look. The question says, how many real roots does the parabola have? In other words, how many times does it cross this this x-axis? Well, it crosses it twice, doesn't it? We can check, and we're correct. Okay, next question. Again, we've got a parabola. We're asked how many real roots does it have? Okay, well, be careful here. It has one real root. It touches at this point right here. It touches at the point 0. Okay, so the point x equals 0, but our answer is 1. It has one real root. Okay, again, we've got a parabola. We can see in this situation here, we're asking ourselves how many real roots does it have? It never crosses the x-axis, and therefore it doesn't have any real roots.